Okay. Now, as I said, right, this particular repo is having all kind of everything, whatever is required for a Kubernetes project to run, with all the manifesto files, which is the .yaml files with the required applications, like the var file or Docker file or whatever, the SQL dump, everything is required. So this is actually a complete application stack, you could say, like the applications, which is the UI part, the application part, and that is actually built in Java. Okay, this is entirely a Java project having a backend with MySQL, having a backend with MySQL, and we'll see how we can. And this particular Java applications, we need to deploy into a Tomcat server, and that Tomcat server we are going to create a pod, and that in that pod we'll have our Tomcat server and our applications will be deployed inside it, right? So now if I just tell you, right, let me just go through all each of them and what are the file explained here. And if you just go through, as I said, right, if you just go through here, all this complete project information, so what is the prerequisites is required, like so many kube installations, kubectl and everything, right? And the pod creation, project setup, everything is there. So what you have to just follow, you have to simply clone this particular repository or just fork it to your repository and then use this one. And what you have to do, you have to just follow and the required commands, simple required commands been written here. See, before that, let me just go through each of these files and let me just explain you what is exactly it contains. And then we'll go ahead and execute this particular project. And I'll just show you step by step how we can execute and what are the objects is required to be created. Okay, now let me first go with the deployment file, and from there we can get everything, right? So whatever you can see here, we have two deployment files. I have written it as deployment definition MySQL db.yaml, and another one is the deployment definition tomcat.yaml, right? So if I just go to this particular YAML file and we'll have the complete details, I can just explain you here. As we had already learned about the deployment, right? The API version, there are the four things you have to consider basically whenever you're writing the main four things, and then later on you need to keep adding all the things whatever is required, right? The first thing is API version, right? What is the API version of this particular object or of this particular project, right? Now, if you see here, this particular deployment API version is app/v1, and you'll be thinking, right? How we'll get this one and how I have to write the manifesto file. As I always said, you right, you have to definitely use and follow their documentations. Any tool you are using, suppose for Kubernetes, you should follow the documentations page, right? Simple things. You no need to go if you don't remember. Also, that's fine because we have this Google where you can find everything. You can just go at deployment in Kubernetes, right? Or Kubernetes deployment, whatever you want. So the first one is the kubernetes.io. You have to go to the docs and there you can find it. Or if you're sure of these particular documentations, if you are into this, and I already have shown you, right, how you can search here. Any object or any resource you want to search, you can simply search in these documentations and you can find it. And if you want to know more about this deployment, just go ahead and find it. What is the deployment is all about, right? A deployment provides declarative updates for pods and replica sets. So you describe a desired state in deployment, and the deployment controller changes the actual state to the desired state at a controlled rate. So we can define the deployments to create new replica sets and existing remove the existing deployments and whatever things you want to do. It has some use cases also, which we already have discussed that one in our previous classes. So as I said, you should know what kind of API version is. So if you just go to their documentations, you can find the API versions which is being used. So you can just go ahead and use this API version and what kind of things you are going to use. It should be deployment, D should be on uppercase, right? So if I go to my uh, repo here, write my code, and you can see here, let me a little maximize this one. So if you just see here, we have deployment and metadata. So this metadata is nothing but the information about the resource, right? What kind of object, you are going to create, all the informations required for that, you have to provide. So the metadata section in the block, you have to provide name of this. You can give any name as per your requirement. And here you can say we have created a name and we want this particular resource or particular object to be created under namespace, dev namespace, okay, under dev namespace. So it's very clear, right, how to create the dev namespace. kubectl create namespace and give the namespace name. That is the simplest way to create it. But if you have to write this one, just go to the namespace definitions, right? It's very simple. API version is v1 for namespace. The API version is okay. Well, namespace is v1 and metadata name is given as v, right? So similarly, if I just go back to the Tomcat file here, so we have this namespace and the labels. We know what is this labels being used for, right? So the labels we have given as Tomcat web app and front end. Type is front end. The name is app Tomcat web app. And similarly, this specifications, as I said, the 4 things you have to just keep in mind: the API version, kind, metadata, and the spec. Spec is nothing but the specification, right? So under specifications, that we have this template, which is for the pod to create. And inside the pod, what we have? We have the containers, right? The pod contains what the pod contains. The pod contains one or multiple pod. The pod contains one or multiple containers inside it. So in these specifications, we have created a template, and this we have given a name to that is called Tomcat Web Pod. We have given as Tomcat Web Pod. This is the template sections and metadata section. This specifications is for the deployment part, and under this template, we have the pod declarations, right? Under this particular template, we have the specifications for the container, right? We have the specifications for the containers. So under these containers, we have given a name as Tomcat Web, which is the container name, and what kind of image you are going to use. So I'm going to use this particular login web app colon 11. Login web app colon 11. And this is going to be pulled from where? Can anybody answer this question, please? We already have discussed many times. How this image and from where it will get? Okay, this image will be pulled from the Docker Hub. This is my Docker Hub account, and this will pulled out. So you definitely you'll now say, right, how would we know that this is the Docker Hub, right? This is just a name. This is just account name. How would you know that this is Docker? See, it could be Docker Hub. It could be your personal or your private server where you store your repository system, right? Binary repository system or tool where you store the images. That account details you need. But if you don't set up, that is required some external setups for those servers, right? Here we are just using this setup for the Docker Hub. Now we have this replicas, which is having 2 replicas and selector, right? These 2 replicas, how this will what will do these 2 replicas? This will create 2 identical pods. This will create 2 identical pods. So these pods, what is required this for these pods? This is required to be connected to each other, right? How it will be identified by this matching the labels which we had created for this particular deployment. And everywhere we had given a type as front end. So this is a match labels, and we are using the selectors to filter out this one, right? So now you understood all those concepts about this Tomcat. So for this Tomcat, as you say, we are using this login web app colon 11. Now let's understand what is this login web app and how would you know that how like what kind of applications are server. This totally, because this is an application server, right? This is the application pod we are going to create, and what that application pod should contain, the pod should contain the applications, right? Inside the container it will be the application, and that application should run by the Tomcat server in our case, right? So this particular image should be bundled somewhere, should be created. Let's understand what is exactly this particular image contains, right? Let's go back. And if we just go to the Docker file Tomcat, right? See, this is what the image, the Docker file is there. Once we build the Docker file, right, it will create that particular image, right? So what I'm using here in this particular Docker file, I'm using the Tomcat 8.5, Tomcat 8.5 version, the base image. Then I'm copying the login web app var, that is the application. This is the Java application. First, what I'm doing, I'm getting the Tomcat 8.5 version of the image, base image, and then I'm copying this var file to this particular web app folder, to this particular web app folder. And the working directory, this is what the working directory looks like, right? What I have to do here, the working directory is nothing but the root directory of the web apps folder where these applications will be deployed. After that, I'm just using the command cmd to start catalina.sh run. It will start the Tomcat server. That's the simplest Docker file, right? The same thing. So what will happen? As if you just go to this particular repository, right? The first thing I have mentioned to create the images out of these two Docker files. First step is to create two images. Here I've given an image name is login web app 1.2 and all, right? So be careful whenever you are just getting it, you need to do some changes everywhere. That's why don't simply copy and paste and start working. You should understand how it is working, right? And what sort of changes do you need to run this project. So you can see here, I'll just give you simple one hint here. When I build this particular Docker file, what will happen? It will create this particular image, right? Login web app colon 1.2. The tag is 1.2. So what will happen if I just go back to this particular definition file, right? And where it is mentioned here is login web app 11, right? That means 1.2 tag is not here, it's given 11. Suppose if you are using directly that command, whatever I have given in the readme file, right? That if you're just copy pasting and using it, that will generate login web app 1.2 versions of image. And but here, so either you can just change the command there and create login web app colon 11. This is up to you what name you are giving, right? And this is also if you can directly give the local. I'll just show you in another file, right? That is what you have to do some changes. Now let's talk about the MySQL DB part. Here in MySQL DB part, there is all other objects like the config map, secrets, right? Services, everything has been set up here, right? Secret maps and all these things. Now let's go ahead here. Same deployment, apps v1 deployment, metadata sections we have given, specifications just given MySQL DB, but type is backend. I have given actually it's a name. You can just write it as per your policy or as per your requirement, right? Now the applications I've given as MySQL DB. You can give whatever you want. The containers. Here I'm using a different versions. It's called MySQL 11 version of MySQL, right? That is the image. And from where this image will get created? This image will get created from this Docker file of this MySQL. What is the? It is using MySQL 5.7.28 version base image. And there I'm just dumping, right? Whatever the dump we have created, it's a DevOps class.sql. This is SQL file which will get copied to the Docker daemon, to the entry point of the Docker daemon, to the container. What will happen? Once the pod will spin up, right? Once the pod will get created, what will happen? It will execute this SQL dump file. That means it will import whatever the SQL statement written in this file. It's very simple, right? So what will happen? It will just get created, and what this DevOps class.sql contains, if I just go to this dump file, and you can see here, I have this particular SQL file which is having, see, it's just simply just creating a table. It's just creating a table, name as user, right? And then all these things available, this column name, right? ID, first name, last name, email, username, password, all these details. Now, this is the file which will get copied, and it will be inserted and create the tables. Good. Now let's go back again. And here, if I just see here, we are clear about this particular image, right? Now let's go about this particular port having container port 3306. Remember, guys, the default port of a container, of the MySQL default database of default port of the MySQL DB is 3306. Okay, so the container port is 3306, and here is what you need to understand. Okay, environment from. Here I'm using the tag environment from. So what it is doing, the environment from, I'm just going to use from the config map references. What I have given, config map. Name I have given db-config. db-config. So, and here the secret reference also, the secret information, the secret data, the environment variables, right? Secret variables, the secret data will get injected to the pod through this one. So I've given a secret references, name I've given db. So what is this db-config and db-secret? This is the name of the config map, what we have given, and this is the name of the secret, what we give. So if I just go back there to the config map, right? Config map, and we have the secret here. Let's go to the config map first. If I just go to the config map, you can see here, I've given a name in the metadata section as db-config. So when we create the config map, it will be named as db-config. It will be simply this one. And in the config map, we have a data section. In this data section, so we have to provide the environment variables and the value. Environment variables and the value. So here the environment variable name is MySQL service host, and the value we have passed it here. And the value we have passed here. Here MySQL underscore database, DevOps class, MySQL underscore user as Ranjit, right? So this is a very plain text, whatever we have given in the config map, as this is not that much sensitive, right? But if I just go back to the secret file here, we have this secret, the passwords, right? The passwords, and here the name is given as db-secret. The password has been encrypted here. The password has been encrypted. Now let's go here, go back to the deployment file, and you can see here MySQL DB and is given as backend. So you now understood here, right? db-config, where we got it, right? So all the config map, whatever the data being created as per the config map with the name of this, it will get injected to the pod. Similarly, for the DB secret also, right? And one more thing here, you could see here, we have used the persistent volume, persistent storage volume, right? What is this volume? We have created a mount point, volume mount. First, we are creating a mount point and name we have given as MySQL hyphen persistent hyphen storage. This is the persistent volume name. And we have given a mount path. This is the path of the container, right? Of the pod of the container, which will get mounted to this particular volume. See, and this particular volumes, we have created this, and we, with that particular volume, we have given the persistent volume claim, which will claim it. First, let's see these two names, which we have first created persistent volume, and then we have created, we are going to claim it with MySQL PV claim, right? Now let's go ahead and check what is this. Before that, we should first create the persistent volume and volume claim, right? So if I just go back to where it is, yeah, MySQL PV, right? Let's go there. In this particular YAML file, manifesto file, I have kept here all the both persistent volume as well as the persistent volume claim. Here API version v1 persistent volume metadata is given, and this should be created under the namespace dev. Under the, remember, we have kept all these details in a namespace called dev, right? Now, if you see here, I have created a persistent volume of the storage 2 gigabyte, right? Persistent volume of the storage 2 gigabyte. Capacity 2 gigabyte. Access mode, we have given read write once, and the path where we have to store the, and here also you need to change the path. Here I have given my laptop's local path where I had created the persistent volume to mount that and to store the data, right? So you have to change this one, the path, while creating the persistent volume. Once a persistent volume is created, some claims should be there, right? You should claim that volume, whatever is there. So similarly, we have to create another persistent volume claim. The kind will be persistent volume claim. C, big uppercase, B in uppercase, and C in uppercase, or else it will not work. Okay. Now the claim name I have given it. See here, MySQL PV claim, and here MySQL PV volume. Now what will happen? Similarly, read write once the and resource request. Here we created capacity. We created 2 gigabyte, right? And similarly, we are going to claim also 2 gigabyte of storage. 2 gigabyte of storage, right? Now, if I just go ahead and check this particular things, like, let's go back here to the deployment here and see this particular volume, and we are going to claim this one, MySQL PV claim, right? And then we are going to create one replica only. It will have one database. It will have one database. Just a few seconds, guys. Okay, guys. So here, if you see here, we have replica, only one database we are going to create, one database pod. And similarly, there is this match labels, right? Selectors, which is going to match the backend, right? So what happening here? So the overall, if you see here, we have two application pod, right? Two UI pod and one database pod, right? So let's go back again. And if I just go, we have this persistent volume and we got all these details, right? Tomcat and G. Okay. Now, once we create this particular, all the details, right? What you have to do, you have to follow the things, whatever is written here. Don't worry, I'll just show you once how it works, okay? And after that, you can just go ahead and find it out, right? First, what is then? Let me just go through here. First, creating the namespace. First, build the images first. Create namespace. Create config map. Secret, right, for the database credentials. Secure the DB credentials. Then persistent volume to store the data, container report data, and then after it gets created, what we can do, we can simply create the deployment. We can simply create both Tomcat as well as MySQL DB deployment. So once this deployment is created, you can just create the services, and this services is node port. So here we have used the node port services, right? So once you create this node port services, what will happen? This will connect to the ports, and from internet we can access. So if you can see here, right, we have this. Once you use this particular command, we have this resources. You can see here what are the config map and all these details available, right? Everything you can see here. And how can access this one also, you can find it out. Now let's go ahead and see what is and how we have to create all this and set up the projects, right? And before that, if I just go to the services, right, everything I just explained you except the services, right? Now let's go ahead and check the service, what kind of service we have created. If I just go to service -ui, you can see here we have the API version, again v1, kind is service, and metadata, and under specifications, right, spec, we have the type, what type of service it is. So how many types of services there? This is questions to you guys. How many types of services we know? Can anyone answer? Okay. So we have three types of services we saw, right? Cluster IP, node port, and load balancer, right? These three type of services we have. So cluster IP is the default services which will be internally used within the pods in the cluster. And through node port, we can connect to the pod from outside, from the internet. And the load balancer will be used the similar traditions way. Okay, but node port is used for development, training, and R&D purposes. So we can use this one. But load balancer, if you want for production side, so you have to use that load balancer one. Okay, and companies, they are not even going to load balance, they're going to use the ingress, that is a kind of a routing mechanism to the different ports. So the ingress, that is not a service, okay, but that is being used to route all kind of communication stack. So here in the node port, we have the port sections. We have the target port 8080. Node port is, we have 30,008. Port is 8080. Default port of the Tomcat is 8080. That's why you have given the, when we create the core pod, right, that will having the port, default port of 8080. Then sorry, then we have this node port 30,008. Similar the selector, this particular service, where it is going to connect. See, here we are using the selector, which we have created the labels, right, selector. So we are using the Tomcat web app and the front is a kind of filtering, which is getting filtered and gets connected to that, right? So services is being used here. Now, if I just go to the database service, MySQL service here, what we have used here, service, we have used under the namespace dev, and that was also under namespace dev specifications. And here we have just used the port 3306, right? Cluster IP non-selected, it is going to connect to the backend. Clear, right? Now what we'll do here, all about the services, we got it, right? So what, okay, any doubt guys so far? Pajan, Rudra, and Mani, you three are there today. So any doubt so far?
No, Rajesh.
Okay. So Pajan, have you covered the Kubernetes, whatever we have covered last 3 to 4 classes? Hello, Pajan, you there? Hello. Okay. So what about Rudra? Okay, no worries. Okay, guys. So what I'm see, I just explained you everything there. So this is a task for you. The Kubernetes classes is over now. Okay, this is a task for you. Whatever I just explained you, what you need to do first, you have to create the Kubernetes cluster using Minikube, right? And you know how to do that. Already we have discussed these things in our last classes. If you're not sure, just refer the previous videos, recordings, and go through create the cluster. After you create the cluster, just on that machine itself, that server itself, clone this particular repositories, and from there you'll find all these YAML file and manifesto file, and then execute one after another the way it is written here, and see, and based on that also you have to change the things whatever I showed you, right? There are many things where you have to change it there. That is the learning for you. Okay, so if you understand how it works and where it is required to be changed, once you change it and start working, then it will be done. That's all guys for today's class. Okay, and we can meet up tomorrow. If you have not done and still down, then tomorrow we'll do this project and then we'll move on for the next tool, that is Terraform. Okay, sure guys, see you then.